Hi, and welcome to a video on drawing Lewis dot structures. In this video, we're going to focus on structures that have double or triple bonds in them, not just single bonds. So this would be the second page of your note packet, which I would recommend if you haven't done this note packet with us in class, that you make sure you have one. You can grab one from the folder on the desk and follow along. Again, the left panel or the left column is used for you to show your work, and the right column describes the steps. There may be some blanks in the right column. You can refer back to the previous page. So on the very first page, most of the steps are written out for you, and the steps in the double triple bond example are the same steps that you found in the regular, which is the all single bonds and a central atom. All right, so let's begin. The very first step in drawing Lewis dot structure, no matter what the structure is, to draw the Lewis dot structure of all atoms in the molecule. And in this case, our molecule is CH2O. So we can see from the chemical formula that we have one carbon atom, two hydrogen atoms, and one oxygen. So I'm going to draw the Lewis dot structure for one carbon, two hydrogens, and one oxygen. Let's start with carbon. Carbon is in group 14. It has 4 valence electrons. And remember, when drawing a Lewis dot structure of atoms, we can start wherever we want. We just have to make sure that before we start pairing up valence electrons, that we give each corner 1 electron. So let's say I start here, I can put an electron here, then go here, then go here, then go there, and I use the both 4. If I have 5, that's when I would start pairing up. The next is Lewis dot structure for hydrogen. Hydrogen is in group 1, so it has 1 valence electron. And then, and there are 2 of them since we have 2 hydrogens in this structure. Finally, we have to draw the Lewis dot structure for oxygen. Oxygen is in group 16, so it has 6 valence electrons. And we can see from the Lewis dot structure that, again, we make sure we gave each corner 1 before we started doubling up, and we doubled up here. The next thing is to pick the central atom, and that's the one with the most unpaired electrons. So I look at all my atoms, I see carbon has 1, 2, 3, 4 unpaired electrons. The hydrogen has 1 unpaired electron, and then the oxygen has 2 unpaired electrons. So because carbon has the most unpaired electrons, that's the one that's going to go in the center, and then that's going to help me for the next step when I start to connect the atoms to the carbon. All right, the third step is to connect all the atoms to a central atom with a single bond. So again, my central atom is carbon, and I'm just going to go ahead and start making some connections here. And it doesn't matter which order you connect it in, as long as you connect the unpaired electrons in each atom to an unpaired electron in carbon. So let's say I started with this hydrogen, I connect its unpaired electron here to carbon. Second hydrogen, I do the same thing using the unpaired electron on the bottom of carbon. And then I have this oxygen, and I'm going to connect its unpaired electron to the leftmost carbon. Okay, so that's the third step done. Everything's all connected. Now the fourth step, and this is where it's going to start differing from the cases where you have all single bonds. In this fourth step, we're asked to check for unpaired electrons. If you're going to have all single bonds in your structure, you should have no unpaired electrons. But if you see unpaired electrons, that means that you're most likely going to have double or triple bonds. So I take a look and I notice that carbon and oxygen have unpaired electrons. And these are their unpaired electrons, unpaired electron on carbon, unpaired electron on oxygen. Now, since these 2 atoms are already connected, see, we already connected them here, I can just go ahead and reconnect them again, and in that way I would make a double bond because it'll be 2 bonds connecting the carbon and the oxygen. So I'm going to aim, whenever I get to this step when I'm checking for unpaired electrons and I'm trying to pair them up with other atoms that have unpaired electrons, the best thing to do is to try and pair the atoms that are already connected. So once again, the carbon and the oxygen are already connected here, so I can just go ahead and easily pair up their unpaired electrons. Okay, so now that I have everything connected, and there are no more unpaired electrons, I can move on to the 5th step. The 5th step says to clean up the structure, and remember, don't forget lone pairs. So essentially I'm going to do what I did if you saw the previous videos. I'm basically going to start by drawing my central atom, which is carbon, and I'm going to go around the central atom and I'm going to figure out, well, what type of bonds are connecting the central the central atom to another atom. So let's start off on the right side. I know that there's a carbon hydrogen single bond. So I just draw a bond straight out to the right with carbon and hydrogen. I'm going to do the same thing on the bottom here. I notice there's another carbon hydrogen single bond. So I'm going to draw a bond straight down. A single bond straight down connecting the carbon to the hydrogen. Now on the left and top of carbon, I notice that there are two lines connecting the carbon to the oxygen, meaning that these positions are taken up by a double bond. So I can either draw the double bond to the oxygen going straight up, or I could also draw it to the left. So in this case, I'm going to just draw it straight up. And now that I have all of the bonds sort of cleaned up, they look like straight lines, not these wavy, loopy lines, then I'm going to go ahead and put on my lone pair. So let's see if we have any lone pairs here. Notice how oxygen has 1, 2 lone pairs. So I need to make sure I put those lone pairs back on the oxygen. And that's my cleaned up structure. If I were to draw the bonds, the carbon-oxygen double bond to the left, my structure would look something like this. All right, so now that I have a cleanup structure, the last step is to check for the octet rule. Basically, I'm going to check my structure, make sure it makes sense. And remember, the octet rule says all atoms must have 8 electrons around them, except for hydrogen and boron. So let's start with our central atom here, our carbon. And what I'm going to do is I'm going to only focus on the electrons that are touching the carbon. Remember, electrons can come in, come in the form of lone pair electrons, like the 2 dots here, or they can come in the form of bonds. Now, these lone pair electrons, are they touching the carbon? No, they're not. They're touching the oxygen. So in that case, we're not going to count them. We're only going to count the electrons that are directly touching the carbon. Starting at the top, I notice that I have a double bond here. Remember, each line represents 2 electrons because what you were doing was connecting 2 electrons with these lines. So each line represents 2 electrons. So there's 4 electrons from here. Over here, I see another bond, 6. And the last one here, 8. So this carbon has 8. And again, each line or each bond counts as 2 electrons. So carbon is good. It has its octet. Let's go ahead and check oxygen now. So again, we're only counting lone pairs and bonds that are directly touching the oxygen. We start at the bottom here. Once again, we see that these bonds, these are double bonds. They're touching the oxygen, 2, 4. So we get 4 from the double bonds. And then we have these lone pair electrons, 6 and 8. So in total, oxygen has 8 electrons as well. It has a double bond with 2 electrons in each line there. And then there's 4 electrons from the lone pairs. Finally, we want to check hydrogen. These 2 hydrogens are exactly alike, so I only need to check one of them. And what I mean by exactly alike, this hydrogen has 1 bond connected to it and nothing else. And this hydrogen has 1 bond connected to it and nothing else. So we're just going to check one of these hydrogens. And I look and I see that there are 2 electrons touching the hydrogen, which is great. And that's what we want because remember, hydrogen is one of the exceptions to the rule. All right, so that's it for this video on Lewis-Dot structures of molecules with double or triple bonds. If you have either you can use a note packet or you can use what's linked in the playlist. I would recommend either redoing or doing for the first time practice set 2 and then go ahead and check your answers. All right, I hope you found this video helpful. Have a quality day.